Welcome back. In this session, we will be discussing about Boise code normal form, that is BCNF. It is in between third and fourth normal form. So after third normal form, we are having this one. Actually, this BCNF is a stricter version of your third normal form. What is third normal form? So there should not be any transitive dependency. So X depends on Y depends on Z, and that should not be the case. If that is the case, we have to remove the transitive dependency, so which means we can decompose the table into furthermore. That is what third enough. The same way, yeah, no transitive dependency. So if it is there, so we have to apply the 3NF and we'll be strictly following the 3NF. That is what called as BCNF or Boise code normal form. So let's see the rule. In BCNF, it is advanced version of 3NF. It is the stricter than the 3NF. So 3NF is not allowing the transitive dependency. So the same rule. So how they are maintaining the stricter, let's see. So a table is in BCNF. Every functional dependent x tends to y, which means y is depends on x. In that case, the x should be the super key. So in last session, we discussed about what is super key. So super key is the superset of the candidate key. Okay. So all the keys is used to set of attributes used to identify the row, right? That is what the super key. So the x should be the super key, or LHS left hand side should be the super key. That is what the fourth point. So for BCNF, the table should be in 3NF, and for every functional dependency, x determines y, or y depends on x. In that case, x must be the super key. A set of attributes should be used to identify the row or tuple. That is what the rule. So let's see the example. So consider the table. So the table is order table, not the customer table. Order table. So order table is having item ID, item name, price, manufacturer ID, manufacturer location. So here also, the item name, item price is fully functionally dependent on the item ID, and manufacturer ID depends on the item ID, and the manufacturer location depends on the item ID only. So what we are doing is we are strictly applying 3NF in that case. So item ID determines the item name and price, so that we are decomposing these three into one table. So we'll be having this one: item ID, item name, item price, and manufacturer ID is the dummy to use to link the second table. So manufacturer ID and the manufacturer location is a separate table. So here manufacturer ID is the super key or primary key. Okay, used to LHS should be the super key or primary key. So here comes over here. So the item ID, item name, item price is the one table. In that LHS, X tends to Y, right? I told you, right? X determining Y, or Y is depends on the X. The item name, item price depends on the item ID. So here these two can be a primary key, or these two can be a super key. Can make a super key. So item ID plus item name combination can make a super key, or set of attributes used to identify the row. That's what super key. So the LHS should be so X determines Y, right? Y depends on X, right? So which means item name depends, item price, item name depends on the item ID. So the left hand side should be the super key. So it is not allowing the function partial dependency, as well as the LHS should be the super key, which means the item ID, item name can make a super key. So this determines item price, and manufacturer ID is a dummy which is used to link the second table. So abruptly we can slice out some entries in a table, right? So though we are decomposing the table in a new table, but this table is has relation with this table one, because these two belong to this is the original table. So that is what the manufacturer ID used to link the second table. So this is the example of the 3NF. Thank you.